Yes, sir.
Yes, sir.
Okay, so I was actually trying to define capacitor, and then I realized that I'm actually not online. Number one, when we talk about capacitor, capacitor is a device which is used to store electric charge. But this definition is not acceptable in Cambridge. So, what is acceptable that we will be discussing today? See, if you want to charge a body, there are two different techniques by which we can give charge to a body. One is known as conduction, and other is known as induction. Now, what is conduction? I hope you remember the basic concept of charging a body. When I say something is positively charged and when I say something is negatively charged, what does it mean? If any one of you can answer.
The object has lost or gained electron.
Loss or gain electron, because in AS level we did this point called possible, and A2 level I discussed this point as well. When you say you are charging a body means either you will be giving electron to the body, so it will become negatively charged, or you will be taking out electrons from the body, so it will become positively charged. So no matter what, it is all because of electron. Gain of electron gives negative charge to the body, and loss of electron gives positive charge to the body. So how conduction actually occur? Let's say we have a sphere. This sphere is neutral. When I say this sphere is neutral, what does it mean? It means that it has equal positive and negative charges. That's why this object is neutral. Neutral means same amount of positive and same amount of negative. So positive negative will actually cancel the impact of each other. I took a rod. That rod is positively charged. If this rod has positive 5 charge, what does it mean? It has actually lost 5 electrons. It is just like you, quite possible, those who are taking chemistry can understand easily. When we say copper loses 2 electron, it become Q plus sign Cu plus 2. When oxygen gains 2 electron, it will become oxide and O power minus 2. So if this rod is plus 5, it means that it has actually lost 5 electron. What I did, I bring this rod in contact with the sphere. Charges always travel from higher concentration to lower concentration. You are in your A2 level. You can understand one thing very easily. Positive charge always travel from higher potential to lower potential, and negative charge always travel from lower potential to higher potential. Do you agree? That positive charge always travel from high to low potential, and negative charge always travel from low to high potential. Now, if you look at this scenario, a sphere is neutral. Neutral means it is zero. Rod is plus 5, so I can say this sphere is actually low potential. This rod is actually high potential. So electron will move from sphere to rod. Now, when electron starts to move from sphere to rod, what will happen? One electron will jump from sphere to rod. So we will remove one electron from the sphere, and as a result of which, one positive is reduced from the rod. Because one electron comes, it will cancel one positive. Then another electron move, another positive disappear, another electron move, another positive disappear, another electron, another positive, and a point is reached when both bodies are at same potential. Now the flow of charge will stop. But during all this process, what has actually happened? The rod which was positively charged is neutral now, and the sphere which was neutral is positively charged now. This is known as conduction. Someone who is unaware of electrostatics work actually will assume that positive charge of the rod jumped to the sphere. But actually, what had happened? Electron from the sphere jump to the rod. Those electrons will cancel the positive charges on the rod, and as a result, sphere will become positively charged. Is it clear? Okay, if it is clear. Yes, Alan Bakar, do you have any confusion?
No, sir.
Okay. Now, next is induction. Quite possible. Few of you remember because few of you were here at Minds in IGCSE level, then you studied here in AS level. Now, this is your third year. So, those who are with me since IGCSE level, they must remember one thing. In physics, the word induction refers to abnormal. In physics, the word induction refers to abnormal. What is the normal way of charging a body? For example, if I want to charge this pencil, what I can do, I will take a silk cloth, I will take a wooden cloth or cotton, and then I will start rubbing it. Rubbing it means the two bodies are in contact, and when two bodies are in contact, conduction can occur. What is induction? Induction means I induce charge on this without even touching it. Just to make this term easier. How to produce electric current? The easier way of producing electric current is cell or battery or voltage source. But remember, we do have motors where you rotate the coil, and because of that rotation, electricity generated. That's why that current was called induced current. Because normal way of producing the current is battery or voltage source. But by moving a current, by moving a coil or by moving a conductor in a magnetic field, you can generate current. That is an abnormal way of production of electricity. That's why in IGCSE level, we used to study electromagnetic induction. Fortunately, in AS level, we didn't have electromagnetic induction. And in A2 level, you will study in detail. So induction means abnormal. Let's say we have a sphere. This sphere is positively charged. And now you won't wonder how come it get positive charge. The way we studied in conduction by using a rod. I put that rod on in contact with the sphere, charges move, and the sphere becomes positively charged. Adjacent to this sphere, we put another sphere. And that sphere is neutral. When I say it is neutral, it means that equal positive and equal negative. But what will actually happen? The two spheres are not in contact, so charge cannot travel. But what can happen? The sphere which is positively charged, it will attract the negative portion of the sphere and repel the positive charge. So what actually will be happening? This sphere will experience some alignment of charges, and those charges will align themselves something like this. All the positive will be shifted to right like this, because positive sphere will repel it, and all the negative will be shifted towards left, because positive sphere is actually attracting them, and this sphere is in the nearer vicinity of this sphere. So because of sphere A, charges on sphere B will actually get aligned. Because of sphere A, charges on sphere B will get aligned. Now, what we can do, we can connect this sphere to ground. This is the symbol of ground. Okay, by the way, this is called ground. We may call it Earth. By the way, do we remember Earth is reservoir of electron? And the term reservoir, I tried explaining when I was discussing thermal physics. The reservoir is something that can absorb anything, that can lose anything, but its overall configuration doesn't change. How many of you remember this point? That what is a reservoir? Okay, and that's Samar, Hania, Meram. Okay, those who attended the session remember it. Just for Alan Bakar, let me quickly review. See, one thing is storage, one thing is reservoir. If any one of you can distinguish storage and reservoir, so it will be great. If any one of you distinguish the two. This is the difference between a storage and a reservoir. Yes, if any one of you wants to explain, you may explain, otherwise I will be explaining. Okay, see, storage means, for example, if we talk about a glass of water, a glass of water is a storage device because it stores certain amount of water. But if you drink some water, the amount of water will decrease. If you pour some water in it, the amount of water will increase. But if I talk about ocean, if you take a glass of water from the ocean, what do you think? Will the amount of water be reduced in ocean? No. If you add a glass of water in that ocean, can I say the amount of water will increase? No. So glass of water is storage and ocean is reservoir of water. All of you knew it. I'm just talking to Alan actually. Yes, Alan, are you getting it?
Yes, sir. So basically, that reservoir is the Earth, right? Because it can lose or gain, like
Yes.
it doesn't make a difference.
Because Earth is reservoir of electron. It has enormous amount of electron. It can remove any number of electron. It can absorb any number of electron without affecting its being neutral, right? So it will remain neutral. Now what will happen? When you ground the sphere B, so you have grounded the positive part. So positive part is actually higher potential. Ground is zero potential. Electron always travel from low potential to high potential. What will happen? Electron will start moving from ground to sphere. When electron moves from ground to sphere, what will happen? They will cancel the impact of positive charges, and in the end, this sphere will actually become just negative charge. This sphere will become negatively charged. So this is known as induction. If any one of you think, so at the end of the day, conduction is happening, that is true. But the thing is, if you just connect this sphere to ground, nothing will happen. Charges are uniformly distributed. This body is neutral. There are no poles. So no electron will flow. So nothing will happen. But because of sphere A, charges in B will get aligned. When you ground it, then you can see the flow of electron. So we should know what is conduction. We should know what is induction. Capacitor is a device.
Sir,
Yes, Alan.
I think when we are doing the earthing, or when we are trying to move the electrons towards the Earth, I think there's some method, like first what you have to attach and then you have to remove back. Can you just explain
Yes.
that point, if I remember
Yeah.
correctly?
Yeah, you remember it correctly, because in IGCSE physics there was exactly a question like this as well. See, the thing is, if you remove the sphere first, the charges which are aligned, they won't remain aligned. Are you getting it?
Yes, sir. Yes, sir.
So first you will remove the sphere A and then you will disconnect it. Okay. Now, capacitor is a device which is used to store electric charge. I'm reminding you again and again because this definition is acceptable at many places, so I remember it as well. But this is actually not a very correct definition of capacitor, because capacitor doesn't store electric charge. I'm explaining again and again. If any one of you write capacitor is a device which is used to store electric charge, you will get 0. Capacitor is a device which is used to store electrical energy. How? Capacitors are made up of two bodies. Those two bodies could be spherical surfaces. Those two bodies can be a thin sheet, or those bodies could be two plates. Normally, the capacitor that we discuss in general is known as parallel plates capacitor. That is known as parallel plates capacitor. How that capacitor is formed? Number one, remember one thing, capacitor works on the principle of conduction and induction. Capacitor is a device which is used to store electrical energy. How? This is something we will discuss now. And I don't think so you have studied capacitor in IGCSE level or in AS level. So what I'm assuming, you are studying capacitor for the very first time. If you have studied at school, it is something else. But in IGCSE level, in AS level, we never studied capacitor, so listen very carefully. Let's say I said we are discussing parallel plate capacitor. So what we will do, we will take two plates. Those two plates will be something like this. This is plate 1. This is plate 2. What we usually do, we will produce a positive charge by some technique on this plate. So this plate got plus Q charge. This plate got plus Q charge. Area of this plate is A. So if I say what is the charge density, you can say charge density is Q over A, because density is given by anything divided by size. Here we are talking about charge density. So I need to divide charge by size. So sigma is surface charge density. I brought this plate close to the other plate. Now other plate is neutral, but what will actually happen? Because of this positive plate, charges on this plate will get aligned in a manner. All negative will be on this side and all positive will be on this side. So what will eventually be happening? I will be grounding or earthing this plate. So what will happen? Electron will move from ground to the plate, and eventually this plate will become negatively charged. So this plate will get minus Q charge. So ideally, the amount of charge on first plate is plus Q. Amount of charge on other plate will be minus Q. So what is the net charge on a capacitor? Can I say 0? Yes. Can I say? The net charge on this capacitor is 0 because one plate contains plus Q, other plate contains minus Q. If you calculate total charge, you will be doing plus Q, minus Q, you will get 0. That's why I said capacitor doesn't store electric charge. So what will be happening here? Remember, if we have two plates, one is positively charged,
Sir, can you
other
repeat
is,
that point?
okay. Let's say on
Because
the
your
first
sound
plate,
was lagging, or I don't know. Something.
okay, see, if I say on the first plate, we have plus 25 coulomb charge. So on the other plate, we will be having minus 25 coulomb charge. If I say what is the total charge, so you will say 25 coulomb plus minus 25 coulomb, your answer will be 0. Yes, Alan, getting it?
Yes, sir.
That's why I said capacitor doesn't store charge, because net charge is actually 0. But we remember one thing. When two plates are placed face to face, one is positive, other is negative, and electric field is set up between the plate. When electric field set up, some potential difference is created between the plate, which is given by this equation, delta V equal E times D. We have used this equation so many times. Do you remember? So when we have concept of potential difference, you must remember potential difference is energy per unit charge. So actually, by producing plus and minus charge on the two plate, you have created a potential difference between the two plate, and because of that potential difference, there is certain amount of energy between the two plates. That's why we said capacitor is a device which is used to store electrical energy. How many of you are getting it? Okay, if you are getting it, these two plates need to be fixed somewhere. So let's say we have a surface on which I can fix these two plates. So you have to decide just one thing. What about this base? This is the base on which two plates are fixed. This base should be conductor, insulator, it could be anything.
I think it should be an insulator, right?
It should be an insulator. Why? Because if this plate is conductor, what will happen? Electron from the negative plate will move towards the plate which is positively charged. So both plates will get neutralized. There is no potential difference. There is no energy. Is this point clear? The two plates of capacitor are always fixed on insulator or something which is bad conductor of electricity or electrical charge. Number one. Now, next. In circuits, capacitors are represented by two parallel lines. One is here, one is here. Do you remember what else is represented by two parallel lines?
The symbol of battery.
Battery.
Battery or cell. But the difference is in a cell, two lines are parallel, but these lines are not of
One
equal
small,
length.
one big.
One is large, one is small, and they are relatively close to each other. Larger one is positive, smaller one is negative. But in capacitor, we draw two lines which are parallel, relatively far apart, and their lengths are actually equal. So this is symbol of capacitor. We will connect this capacitor to a cell. So this is one Y, this is other Y, and then we will connect it to the cell. So let's say this is positive terminal and this is negative terminal. This is plate A and this is plate B. What will happen? This positive plate will remove electron from plate A. Initially, both the plates are neutral. When both the plates are neutral, so what will be the potential difference between A and B? Zero. So let me do one thing. I'm writing here potential difference VA minus VB, right? And voltage of this cell is, let's say, 10 volt. Now 10 volt means it can provide 10 joules per coulomb. Initially, charge on A and charge on B is 0. When charge on A, charge on B is 0, then this potential difference is 0. Now what will happen? Positive plate will remove electron from A. So one electron will jump out of this plate. So what will be happening? This plate will acquire one positive charge. Now that electron will move through the cell and will be deposited on plate B. So now charge is not 0. So it means that there is some value of potential difference. Let's say this potential difference is 1 volt. Now, there is a potential difference between the two plates of the capacitor. There is a potential difference between the two plates of the cell. Which one is large? Cell. So every time the cell will win, the cell will keep on removing electrons. So what will happen? More and more electron will be coming out of plate A. When more and more electrons are coming out of plate A, more and more positive is appearing on plate A and more negative is appearing on plate B. So can I say this potential difference will increase? And a point is reached that this potential difference will become 10 volt. Alan, you want to say something?
No, sir. My mic was open. So.
Okay. So how many of you are actually comprehending this point? That when you connect a capacitor to a cell, the capacitor will keep on absorbing charge till the potential difference between the plates of capacitor doesn't become equal to the potential difference of the cell. So this is the rule. Now what will happen after this? From where charge will move? Yes. Now what will happen? Will charge move from cell to capacitor, capacitor to cell, or charge won't move?
Charge won't move.
Charge won't move, right? So this is what I was trying to explain. A capacitor can receive charge from a cell till the potential difference between the plates of capacitor doesn't become equal to the potential difference of the cell. I mean, if you remove this battery of 10 volt and connect a battery of 15 volt, charge will start to flow again. Charge will start to flow again till the potential difference between the plates of capacitor doesn't become 15 volts. So this is a very important result that you need to remember. A capacitor can receive charge from a cell till it doesn't become, its potential difference doesn't become equal to the potential difference of the cell. Now, Related to capacitor, there is a concept which is known as capacitance of a capacitor. I hope one thing all of you must be getting, that when capacitor receives charge, the potential difference between the plates increases, right? When capacitor receives charge, the potential difference between the plates increases, right? Okay. So that amount of charge, the amount of charge that can increase the potential difference between the plates of capacitor by 1 volt is called capacitance of capacitor, is known as capacitance of capacitor. Okay, so this is the definition of capacitance of capacitor. In fact, the amount of charge that can increase, instead of increase, let's make it little better. Instead of increase, use the word change. The amount of charge that can change the potential difference between the plates of a capacitor by 1 volt is called capacitance. Why did I replace increase by change? Why? Let's say capacitance of a capacitor is 2. Capacitance of a capacitor is 2. It means that when it receives charge of 2 coulomb, its voltage will increase by 1 volt. At the same time, if it loses charge of 2 coulomb, the voltage will decrease by 1 volt. Is it making sense? That's why instead of increasing, I use the term change. So what we have said, that amount of charge which can cause a potential difference of 1 volt is known as capacitance of capacitor. Is known as capacitance of capacitor, right? So it means that capacitance of a capacitor is equal to charge per unit volt. Is it right? Can I write capacitance like this? Capacitance denoted by C. Capacitance is charge per unit potential difference. And you can say Q is equal to CV. Q is equal to CV. This is the basic equation for capacitance of a capacitor that relate charge, capacitance, and potential difference. Now, if we talk about capacitance of a capacitor, this capacitance of a capacitor can also be calculated by number of equations, which is not part of the syllabus, but derivation is not part of the syllabus. It will be great if you remember those equations. Capacitance is given by A epsilon naught over D. Because I knew that I will be teaching this equation, so I took care of these symbols since the beginning of this topic. So any idea what is this A?
Overlapping area.
Okay, A is area. And what is D?
Separation of the plates.
Separation of the plate. If you look at this, A was area of the plate. You can see here, A is the area of the plate, right? And I use D as the separation of the plate. So when we are talking about capacitance of a capacitor, capacitance of a capacitor actually depends upon geometry of the capacitor. And when I use the terminology geometry, it means that area of the plate and distance between the plate. So let me write here as well. A is area of each plate of capacitor, and D is distance between the plates of capacitor. And I hope you remember this epsilon naught is basically permittivity of free space. This epsilon naught is actually permittivity of free space. Now, if you put some dielectric between the plates of capacitor, I hope you remember the concept of dielectric. I tried explaining in Coulomb. So what is dielectric? I mean, is it conductor or insulator?
Conductor.
Dielectric. But by the way, dielectric was insulator. Dielectric is not conductor. Remember, if I'm not wrong, I tried explaining when we talk about dipoles. In dipoles, we have plus and minus, and those dipoles are randomly aligned like this. Plus of one is towards minus of other. When we bring a positive charge near them, then they align themselves. Do you remember something like it? During the discussion of Coulomb's law, I tried explaining this point. Remember one thing, dielectric is basically insulator. What we usually do between the plates of capacitor, see this capacitor, for which I have written this equation is this one, where we have two plates. Area of each plate is A, distance between the plate is D, and between the two plates, we have free space. And between the two plates, what we have? Free space. If you put some dielectric between the plate, what does it mean? This is first plate of capacitor. This is other plate of capacitor. And what we did, we put some dielectric between the plates, some insulator. Naturally, between the plates of capacitor, you can never put conductor. Otherwise, capacitor will never store charge. I hope you can understand it now. If you put some conductor between the two plates of capacitor, charge will move from one plate to other plate. So charge won't be stored. So it should be some insulator. It should be some insulator. In the presence of dielectric, what actually happened? Area of plate is A, separation of the plate is D. This dielectric has relative permittivity of epsilon R. Now, capacitance of capacitor is given by A epsilon naught epsilon R over D. Now, those who have attended all the sessions on Coulomb's law, they should be able to understand this thing. Remember the value of epsilon R? Any one of you? Can this value, there's a certain condition for this value, that this value should be less than this, can't be less than this, or always greater than this?
It's always greater than permittivity of free space.
Okay, anyone else? Yes, Alan, you were trying to say something because you raised your hand.
No, sir. It was just up there.
Okay,
I forgot to.
it's totally fine. So those who forgot, by the way, can any one of you tell me, did I ever explain relative permittivity? Epsilon R?
Yes, sir.
Because I specifically remember I did try to explain this. See, this epsilon R is always greater than 1. Why? Because permittivity of a medium is given by relative permittivity into permittivity of free space. Now this permittivity is the minimum value of permittivity. So it means that epsilon will always be greater than epsilon R. And if epsilon is always greater than epsilon R, it means that epsilon naught, it means that epsilon R is always greater than 1. Because if you put epsilon R equal to 1, permittivity and permittivity of free space will become equal. And if you put epsilon R less than 1, permittivity will become less than epsilon naught, which is not possible. Are you people getting it? Yes, Alan, are you getting it? Alan, can you hear me? Okay. So what do you think? Which capacitance should be large? Capacitance in the presence of free space or capacitance in the presence of some dielectric? Yes, which one should be more? C or C dash?
C dash.
Sir.
Okay, can you hear me now?
Yes, sir.
Okay. So just give me 5 to 10 seconds so that I can show you my screen. Okay, can you people see the screen now?
Yes, sir.
Okay. So my question was, which capacitance should be large, C or C dash?
C dash.
C dash. Because epsilon r is always greater than 1. If you look at this equation, this whole thing is actually C. So it will become C dash equals C times epsilon r. So epsilon r is C dash over C. So from here you can get a definition of dielectric constant. The ratio of capacitance of a capacitor in the presence of dielectric and capacitance of capacitor in the presence of free space. So this is short discussion. What is capacitor? Capacitor is a device which is used to store electric charge, electric energy in fact. Now, how will you calculate that amount of energy? That is pretty simple. If I plot a graph between charge and potential difference. Let's say I plot a graph between charge and potential difference. So what kind of graph you people are expecting between Q and V?
Straight line graph.
A straight line passing through origin. It
Origin.
should be a straight line passing through origin, because Q and V are actually directly proportional, because capacitance of a capacitor is a constant quantity. So if you look here, you could have concluded that Q is directly proportional to V because C is a constant. Okay, so I can say if I need energy stored by capacitor, I will be calculating area under this curve. Now, if you want to calculate area under this curve, you will drop this perpendicular and you will be calculating this area. Now, if you want to calculate area under the curve, what you can do, it's a triangle actually. And how to calculate area of a triangle, if any one of you remember?
Half base times height.
Half of base into altitude. So base is actually Q, the amount of charge, and height is actually V, the potential difference. So if you need energy stored, you will say energy stored is half of base into altitude or height. Here base is Q, altitude is V, so energy is equals to half QV. Since we know that Q is equals to CV, so E is equal to half CV into V, it will become half CV squared. This is the energy stored in a capacitor. So the energy stored by capacitor is given by half CV squared. Now these capacitors can be connected in two different modes. One is called series combination, one is called parallel, quite possible few of you remember. In AS level physics, you discuss series and parallel combination of resistors. Here we will be discussing series and parallel combination of capacitors. So let's talk about series combination of capacitors. So if I'm talking about series combination of capacitors. So when we talk about series combination of capacitors, what we will be doing? We will take three different capacitors. Let's say this is capacitor 1. This is capacitor 1. This is capacitor 2. And this is capacitor 3. Each capacitor has its own capacitance, C1, C2, C3. Series combination means one after another. So you will take a piece of wire and connect these capacitors like this. And then you will connect it to some cell of battery or voltage source. This is plus. Now this time I'm drawing battery. I hope you remember one positive, one negative is a cell. When you combine two or more than two cells, you will be getting a battery. So it will be something like this. C1, C2, C3, they are connected in series. Now, what will actually happen? This positive plate will give plus Q charge to this plate. As a result of which, what charge is induced on it? Minus Q. As a result of which, what charge is produced on it? Plus Q, minus Q, plus Q, minus Q. By the way, it will be very easy for you if you start looking from the rightmost plate. How? This negative charge, negative terminal of the battery will give negative charge to the second plate of C3. I'm talking about this plate. The negative charge of the battery will give negative charge to this plate. Now, once this plate becomes negative, it will repel the electron of the next plate. those electron will move through this wire and deposit it on the second plate of C2. So can you see the second plate of C2 become negatively charged? Now these electron will repel the electron on the next plate through that wire. They will deposit on the second plate of C1. Are you people getting it?
Sir, could you
Yes, sir.
like I'm a
Okay,
little
see.
bit confused.
No, let me repeat. What I'm saying, the negative terminal of the battery will give negative charge to this plate. This plate. Now this plate become negative. It will repel the electron of this plate. So this plate will become positive and those negative charges will conduct to this plate. So this plate will become negative. It will repel the electron of this plate. It will become positive. Those electrons will deposit to this plate. It will become negative. Yes, Miram, are you getting it now?
Yes, sir.
Okay, so this way, capacitors in series will keep on getting charges. Now, what you will agree, the way these capacitors are getting charges, can I say all the capacitors will receive same amount of charge? Yes, it is right or wrong?
Yes.
That all the capacitors will receive same amount of charge. So it is right. In series combination, charge on each capacitor is the same. Charge on each capacitor is the same. Now, if charge is same, then voltage is divided. This is what used to happen in series combination of resistors as well. Current stays the same and voltage is divided. Now, voltage is divided according to capacitance because we know that Q is equal to CV, right? Since Q is same for all, Q is same for all. So it means that it will become C equal Q over V. So can I say C is inversely proportional to V? Are you getting it? The capacitor which has largest capacitance will be getting the smallest potential difference. And the capacitor which has smallest capacitance will be getting the largest share of voltage. How many of you are actually getting it? Yes, Mira, I'm confused.
Yes, sir, a little bit.
Okay, see, what I'm saying, Q is equals to CV. In series combination, Q will remain same on each capacitor. So when I write C equal Q over V, can I say Q is a constant? So formula will become C equal constant over V. So can I say C is inversely proportional to V?
Yes, sir. Yeah.
So it means that the capacitor which has more capacitance will receive less voltage. And the capacitor which has less capacitance will be receiving more voltage. Miram, is it getting clear?
Yes, sir.
Yeah. What about you, Alan Wakar? Are you getting it?
Yes, sir. I'm getting that.
Okay. If you get the idea, what you can do, you can just raise your hand because everyone raise their hand so that I know all of you are getting it. Anyways, so what will be happening? Voltage will be dividing. So voltage across C1 is V1, C2 is V2, and C3 is V3. But one thing is for sure, total voltage V is divided. So V equal V1 plus V2 plus V3. If I start putting the values of V, you can say, sir, V is actually equal to Q over C. So V1 is Q over C1, V2 is Q over C2, and V3 is Q over C3. Are we getting it? Because Q will remain same for all. Yes, Mira. Still confused?
No, sir, sir, I get it. I just did not raise my hand.
Okay. So V is given by Q over C. Now what we can do, these three capacitors when connected to the voltage source receive charge Q from the battery. So what we can do, we can replace all these three and just bring one capacitor of capacitance C. I connected this to the same voltage source. I connected it to the same voltage source. So this is positive. This is negative. What I say, it receives same amount of charge Q. So can I say this capacitor is equivalent of the other capacitor? Because what was the concept of equivalent capacitor or equivalent resistor in AS level? Equivalent resistor was the resistor that would be receiving same amount of current from the battery as obtained by the entire combination. It is same thing here. Equivalent capacitor is the capacitor that receives same amount of charge from the battery as received by the entire combination. So we can say Q equals CV, V equal Q over C, equation number 2. If I equate 1 and 2, because left hand side of both equation is actually V, if I equate them, I will end up with this thing. Q over C, Q over C1, Q over C2, Q over C3. So you can see, you can take Q as common from right and they will get cancelled from the Q on left. So we will end up with this thing, 1 over C, 1 over C1 plus 1 over C2 plus 1 over C3. What we can say, when capacitors are connected in series, the reciprocal of equivalent capacitance is equal to sum of reciprocals of individual capacitances. How many of you are actually getting it? When capacitors are connected in series, the reciprocal of equivalent capacitance is equal to sum of reciprocal of individual capacitances. And I hope you remember the concept of this reciprocal thing. If C1 is, let's say, 2 microfarad. By the way, I forgot to mention the unit of capacitance. Capacitance is coulomb per volt, which is known as farad, So C1 is 2 microfarad, C2 is 4 microfarad, and C3 is 6 microfarad. If I connect them in series, so I can calculate their equivalent how? 1 over C equal 1 over 2, 1 over 4, 1 over 6. So it will be 12. It will become 6 plus 3 plus 2. It will become 11 over 12. This is 1 over C. So the value of C will be 12 over 11. And if I simplify it, what I will be getting? 1.08. 1.08 microfarad. Now, what you will agree? 1.08 is actually less than the smallest value in the combination, 2 microfarad. So what we say, when capacitors are connected in series, the equivalent is smaller than the smallest value in the circuit. So what I can say, C equivalent is less than smallest C in circuit. So parallel combination of capacitors is used where you want to decrease the value of capacitance. Why we do it, we will be discussing it. Are you getting this derivation? Let me show you the entire derivation. Is it clear? Okay, if you people are getting it, can you drive a similar equation for parallel combination? Just give it a try. But you have to do all the working. I don't need the final result. Once you have driven it, what you can do, take the picture of your working and send me on WhatsApp so that I can make sure you have actually did all these steps. So this is series combination of capacitors. I'm interested in parallel combination of capacitors. So I want all of you try driving an expression for parallel combination of capacitors. Just give it a try and see what happens. Okay, so I receive answer from Anas and Alan Wakar. Hania, Miram, Samar, are you done? Yes, Hania, Miram, Samar, are we still solving?
Sir, I sent it to you long back.
Yeah, same, same.
Okay. It is not long back. It is exactly 3 minutes before.
Yeah, I know, like
So
2 minutes ago. Yeah.
okay, what about you, Summer? Okay, Summer left the class. Anyway, so all of you are getting the same result because in parallel combination, let me quickly review. In parallel combination, we will be having three capacitors, all are connected across the same two point. When all are connected across the same 2 points, what will be happening? The potential difference across each will be the same, that is equal to voltage. But the total charge will be divided into three parts, Q1, Q2, Q3. So you will start with this one. Q is equal to Q1 plus Q2 plus Q3. Q1 is C1V, C2V, and C3V. Because V will remain the same, then you will replace the combination by equivalent. So Q equals CV, you will end up with this thing, C1V plus C2V and C3V. And finally, C equals C1 plus C2 plus C3. So when different capacitors are connected in parallel, equivalent capacitance is equal to sum of individual. So it means that this C will be greater than the largest C in this circuit. Are you getting it? The C will be greater than the largest value of C in the circuit. So we should know what is series combination, what is parallel combination of capacitor. If you people are getting it, now we may try solving some question. Okay, so this is question number 1, page 55. Those who got the booklet, they can start solving this question. And if you don't have the booklet, you can see question on the screen as well.
Sir, can you shift to the next page? Scroll down. Thank you.
Okay, I guess all of you are done solving it, but unfortunately, we have just 2 minutes left. So I will be discussing the answer in the next hour. Let me take your answers. Okay, for B1, are we getting 4x squared minus 11? I'm just telling you the answer. If you are not getting these, I will surely solve question next class. 4x squared minus 11, right?
Yes.
Okay. In B2, we were supposed to calculate the value of charge. Is it
I'm getting minus 9
2.8?
something.
You are getting minus 9? Did you do the
Yeah.
conversion distance in centimeter?
Yeah,
We
for the
were
first
supposed
one.
to use.
And
No, I mean, did you convert this 36
oh yeah,
meter
yeah.
into
Sorry.
that? That's why you are getting minus 9. Anyways,
Yeah,
for
I think
charge,
I
are
made the
we
mistake
getting
there. Yeah.
okay? So are we getting 2.8 exponent minus 5 for
Yes.
charge?
Yes, sir.
Yes, sir.
Okay. And when they say calculate the energy dissipated, are we getting 8.6 joules?
Yes, sir. Yes, sir.
Yes, Anas, Anya, are we getting the same? Okay, so in next class, if you people are not getting these because we have to discuss few more parts in this question, I will discuss the solution of this question and we will be practicing more questions. So I will resume from here in next class.